Okay, marhaba. These are the grids for geometry, periodic, tomorrow, week 6, term 2. Before we start, uh, I'm gonna shout out Yahya Azam, Muhammad Sars, and Adnan, and also Kareem, uh, because I missed the penalty, فيعني I kinda have to shout them out. فيا shout out to them. Uh, خلاص, let's start. We have grid number 1 from 4.6. uh, sorry, no, we have question 25, question 27, question 30, 32. بيطلعوا 5 grids. مهم بيطلعوا 5 grids. page 42 42 question 25. Okay. uh, I, I never knew how to do these. I remember in the AMS we would always just pick out each choice, but how you do it, this is actually how you I actually find out. أول شيء, you change your calculator to radians. Okay. Change your calculator to radians, uh, and you do, since we need to find theta, you have to take sine to the other side. So theta will be inverse sine of radical 3 over 2, and you get شو اسمه pi over 3. Your calculator should give you pi over 3. Make sure it's on radians. If it's still on radians and it gives you a decimal answer, then your calculator is tweaking. Okay, I'm sorry. Get a different calculator for tomorrow. That's pretty much your only hope. المهم, you'll get pi over 3. Now, what you do with this pi over 3, you always put, since we're talking about radians, usually we put 360k. But since we're talking about radians, we can't put 360. You put 2 pi k. Okay, 2k pi, whatever. This, you could say 2k pi. 2k pi. Whoa, what? مهم. You put plus 2k pi. So you have two answers. The first answer will be whatever you get here, this number, and you always put after it plus 2k pi. Okay, so you'll get, it will be 4 pi over 3 plus 2k pi. But there's always two solutions for sine. Okay, whatever answer you get here, you have to put pi minus answer. You know the answer you get in the calculator. So whatever answer you get here, whether it was pi over 6, pi over 7, pi over 9, 2 pi over 4, 3 pi over 4, 5 pi over 2, whatever, after you get it, you put pi minus that answer. And your calculator will give you 2 pi over 3. Obviously, the answer being without 2k pi, huh? The answer being pi over 3. Okay, so you put pi minus answer, which is, I put it in pi over 3. Okay, your calculator will give you 2 pi over 3. And always, you have to put 2k pi after it in your answer when writing it down. In the written, if this comes written, if it comes computer, whatever. Okay, usually when it comes computer, they give you multiple choice, you can just check it. But if it comes written, you write down the steps. If you write this, you get full. You write theta equals inverse sine of radical 3 over 2, and you're gonna get theta equals pi over 3 plus 2k pi. Okay, then on your written, you also write theta equals, you could say theta 1, theta 2. Theta 2 equals pi minus pi over 3, always pi minus the answer, equals 2 pi over 3, and you put plus 2k pi. If you write this, you get full. That's it. There's nothing else. شو بعد في question 27. This one. Okay. This one you need to use the identity. 1 over 3 cosine squared plus sine theta equals 1. Okay. They want it between 0 and 90 degrees. Okay. We know that cosine squared equals 1 minus sine squared, if you remember the identities from the previous recording. Okay. Instead of cosine squared, we can put 1 minus sine squared. But before we start solving, I don't like solving with fractions. Okay, I don't like solving when I have a fraction, especially when I'm substituting. Okay, uh, so what I do is, since I want to get rid of this over 3, I just multiply 3 by the whole equation. Okay, so 3 cancels with 3, then I get 3 times sine is 3 sine. So 3 cancels with 3, become cosine squared. Then 3 times sine is 3 sine. Then 3 times 1 equals 3. So like this, you just cleaned up everything. It's way easier to solve like this when you don't have a fraction as a coefficient. So instead of cosine squared, we substitute 1 minus sine squared. At 1 minus sine squared plus 3 sine equals 3. Okay, let's take everything to the other side. Okay, you'll get minus 1. 1 becomes minus 1. Take it to the other side like this. Minus 1 minus sine squared becomes plus sine squared. And plus 3 sine becomes minus 3 sine. And we have this plus 3 at the end. Let's substitute. Let's just clean it up a bit. Simplify. Minus 1 and 3 gets you plus 2. And you have sine squared minus 3 sine. Okay, and you guys know how we solve this. You factor it, always equals 0, huh? Okay, equals 0. Everything always. You factor this, and you factor it as if you're solving x squared minus 3x plus 2. If you remember my recordings for the AMS. How do you factor this? You'll end up with x minus, I think it was 2, and x minus 1. Okay, but in your answer, if you put this, you're going to get it wrong. Okay, you have to write sine minus 2 and sine minus 1 equals 0. Please don't make silly mistakes and not putting 0. Obviously, depends on the corrector, but you could lose marks if you don't put equals 0, okay? And then you write down, you get sine equals 2, sine theta, huh? And sine theta equals 1, okay? And I'm going to write these just in case maybe they deduct marks. So always put theta, or x, or whatever you're talking about. In the question, they put theta, for always put theta, okay? So you get two things, sine theta equals 2 and sine theta equals 1. Okay, أول شيء you have to know sine cannot exceed 1. So this is rejected. You're right, this is rejected. Okay, this is rejected. So sine equals 2, that's wrong, it's rejected, because if you try doing shift sine 2 on your calculator, it gives you math error, because the sine function is always in between 0 and 1. Okay, so this will be rejected. You write down on your paper rejected, and I don't know, put an X on it, whatever. Okay, and you get sine theta equals 1. How do you find theta? Theta equals inverse sine of 1, and you get theta equals, should be 90 degrees, if I'm not wrong. Okay, and they said it's in between 0 and 90, so you don't do 180 minus 90, you don't do pi minus 90 after doing shift sign. No, since they said it's in between 0 and 90, one solution is all you need, so theta equals 90 degrees. Okay, if you write this down in your written, it will be, you'll get 100. Show that you got rid of the fraction by multiplying by 3. Always write down the identity, which is cosine squared equals 1 minus sine squared over here, and then continue solving. Okay, question 30 now. I'll put it here. Given our ST, with ST is 10 radical theta, let's just draw it. Hey, okay, R, S, T. Okay, ST is 10 radical 3. Angle R is 30. And T is 60. What is the value of RS? Okay, you should all know this is easy. Sine rule, you do sine 60. You always start with what they want. So RS, which is T. So sine T over T equals sine R over R. You'll get sine 60 over T equals sine R sine 30 over 10 radical 3. You cross multiply. What do you get? Let me see. You should get, yeah, okay, T equals 30. Okay, that's the answer. Question 32 on my record. Yeah. Again, triangle XYZ, draw it. A, okay, okay, XYZ. YZ is 12, XY is 7, angle Y is 60 degrees. What is XZ squared? أكيد they're asking use cosine rule. Okay, XZ squared, what's the cosine rule? Equals the other two sides squared, 7 squared plus 12 squared minus 2 times other two sides, 2 times 7 times 12 times cosine of the angle 60. Okay, do this in a calculator. I'm just gonna check the answer because the calculator isn't beside me. 109. Yeah, 109. If I get xz squared is 109. If they ask for xz, obviously xz would be radical 109. Okay, but they just want squared if I keep it like this. Okay, this is the last grid question before I go on to showing you how to graph the sine functions. Uh, over here, the sine and cosine, because those might come written also. Uh, here you have, it's a grid, so it might come computer. You have well, you have one big triangle, okay? And obviously you can see there's a triangle here and a triangle here. Last year we took, whenever you have a right triangle like this, okay? A right triangle, a big right triangle, and it's divided into another right triangle, then the theorem was that these two triangles are similar. Okay, the small one, the small. Oh, what the fuck did I go? Oh, where'd I go? Oh, okay. Let me write it again. Okay, مع بعض. uh, the theorem was إنه these two triangles become similar. Okay, what does that mean? Okay, let's name this. Okay, in the exam they'll probably name it for you. I'll name it like this, A B C, and I'll put M here. Okay, this triangle ABM will be similar to the smaller triangle, but you have to be be precise. You can't just say BMC. Okay, it would be wrong. You can't just write it like that. Okay, how you do, well, technically that's correct, by the way, but how you do it is obviously well, it's not obvious, but this angle over here at the bottom left is equal to the angle at the top right. Okay, and this angle here at the bottom right is equal to the one at the top left over here. For angle A will be congruent to angle B. So you say B, and then angle B, which is over here, is going to be congruent to angle C, top left, bottom right. So you put C, and then angle M, which is the right angle, is obviously congruent to the right angle over here. So you put M. So you have to be precise when naming your similarities, because if you put the similarity wrong, you're going to get the whole question wrong. Again, the person correcting won't bother. He'll just put your question wrong. You'll put your answer wrong. So always, and I'll write them down in colors. Oh, wait, undo. Hey, uh, I'll put the red angles are congruent, the bottom left and the top right, and the blue angles, top left and bottom right. The opposite ones are always equal, like this, okay? For what's important for you to this triangle. Now, what do you do after you find this, okay? Now we want tangent of theta, okay? Tangent of theta is يعني opposite over adjacent. Okay, what does that mean? يعني the opposite of this angle, which is 10, over adjacent, which is BC. I'm telling you from now, it's impossible to find the side. It's too hard because you don't have any angles and you don't even have two sides. This side is a small side. It's for another triangle. So you won't be able to find opposite over adjacent. However, if you know B and C are congruent, يعني this theta and this angle over here are congruent, then you can just use the tangent of this angle over here. And that's how you solve actually. So tangent of theta is actually the same as saying tangent of, I'm not going to say angle B, I'm going to say angle ABM. Okay, you have to give the exact angle, ABM. Okay, because they're congruent angles. And can you find the tangent of angle ABM? By the way, write down because they are congruent. They are congruent. Okay, just for the person correcting. Why are they congruent? Because they said the triangles are similar. Okay, that's why. Because the triangles are similar, they're congruent. Okay, uh, after you say the congruent and you say this tangent is equal to this, can you find the tangent of ABM? Yes, you can. You can say the tangent of angle ABM is equal to the opposite of ABM, opposite which is 8, over the adjacent which is 10, which is simplified, you get 4 over 5. So your answer is part B. Okay, this is all you need to write. Really, that's all you need to write if it comes written. هلا we'll do, before I continue, by the way, question 21, I think it was. I solved it correct in my شو اسمه in my recording, but our math teacher today told us that the solution in the file for the solution is wrong. Okay, I remember we got 5 cosine x equals 1. We divided by 5, you get cosine x equals 0.2, and to find x you do inverse cosine, okay, of 0.2, and you get, I think it was 78.5. Okay, but there's always two solutions. Okay, how do you find the second solution? If it's cosine, the second solution is 360 minus answer. Remember how we had for sine, it was pi minus the answer? For cosine, it's always 360 minus the answer. In other words, if it comes radians, which maybe it doesn't, but just in case, 2 pi, because 360 is 2 pi. So it's always two solutions when you have inverse cosine or inverse sine, except with sine, it's 180 minus the answer. For cosine, it's 360 minus the answer. So it will be 360 minus 78.5. And your second solution, x2, it should be x2, and here's x1. x2 will be, I think it was 270 something. It's not here actually. It's not in the solution because the solution is wrong. But it will be 360 minus 78.5, 281.5. 281.5. Not only did our math teacher tell us this was wrong, but she also said that the question, how it came, was they'd ask you to solve graphically. Okay, so there would be a part C. The same way in part B we graphed sine x, which was like this. Oh wait, my mouse ran out. Wait, let me write it again. It's We drew sine x, which is like this. Whoa, 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 my fault, my fault. Last one, last one, last one. Wait, sine x, which was, it had a point at 90 here, 180 over here, -1, and the 1 over here. It goes up to 1, comes back down, goes back up, and finishes. This is sine x. Not only did our math teacher say part A was wrong, but she also said part C, they say solve graphically. شو اسمه sine x equals cosine x. How you do this is, all you have to do, just look at the graph you have, see where these two intersect. Over here it intersects at somewhere between 0 and 90, which is 45, and over here it intersects at somewhere between 180 and 270. You'll say 225. These are your two solutions. Okay, you'll get x equals 45 and x equals 225. Also for part A, they said maybe they say cosine x equals 0.2, and they ask you to graph it, to solve it graphically. Solve graphically. How would you solve this graphically if it came? You have to draw the vertical line of 0, the horizontal line of 0.2, which would be over here, 0.2. You draw this. Okay, make sure to get a ruler in the exam, like this. And then you just take the intersection points. If they said for 0.2, not even 0.2, if it was any other number, okay, you just draw the line like this and see where they intersect. That's how you solve this one. But I'm gonna do, they'll probably bring this, and I'll do this one, and I'll do tan. Okay, because why not? Yeah, I'll do tan. Okay, so the first one, question 15, I'll just write it over here. Graph y equals 3 sine x. Okay, and I'll also give you y equals sine 3x, not 3 sine x, 3x. So I'll put the graph like this. I'll give you this. Okay, here's the first step. Let's start with 3 sine x. Okay, the first thing you do to any graph, if it was cosine, if it was sine, is put in your spacings. It starts 90, then 180, then 1, 2, 3, 270, and 1, 2, 3, 360. This is the first step to solve. Okay. The second step is put your height. Let's say our height, it's always 1 and -1. This is your basic graph. So what's your job in that? Now, after you put your basics in, you look at this. Since they're saying 3 sine x, you're multiplying it by 3. What did we say A was? A was the amplitude, the height, the highest point. If A is 3, what do we have to change this 1 to? 3. And what do we have to change this -1 to? -3. And you graph normally. We know at 90 there's one here, at 180 there's one over here, at 270 there's one over here, and 360 there's one over here, and you just connect the dots like this. Okay, an easier way is to just graph sine x. Graph sine x if you want. Sine x, okay, forget about the 3. Let's say sine x, we want to graph it. We know there's one at 90, one at 180, one at at -1, 270, one at 360, like this. Graph it. But after you graph it, we graphed y equals sine x. We want 3 sine x. What can you do? You can just, with your eraser, replace 1 and -1 and put 3 and -3. That's it. Okay, but what if they asked sine 3x? Same thing for sine 3x. Same steps. Graph y equals sine x. Graph it normally. Put a point here, point here, point here, point here. Go up, take it up, go down, back up. Okay, what do you do? Except now, when we have, this is B, right? B means you're changing the period. What do? You take each period and divide it by 3, or each coordinate and divide it by 3. For this 90, put 90 over 3, 180, put it over 3, 270 over 3, 360 over 3. Obviously, in the exam, if you just put over 3, you're going to get it wrong, right? So just take your eraser, put 90 over 3, which is 30. 180 over 3 becomes 60. 270 over 3 becomes 90. And 360 over 3 becomes 120. This is how you solve, okay? And obviously, it goes, yani, if it's 120 over here, it's going to be 150. Here is going to be 180. Here is going to be 210. Here it's going to be 240. And so on and so forth. It goes back up, back down, back up, like this. Okay, if you get what I'm trying to say. For the easiest way for those yani, who get yani, mixed up and whatever is draw y equals sine x normally, and then if they're talking about a, you just change the height. If you're talking about b, you just divide each coordinate by 3 and obviously fix the number. Okay, so what if they said y equals 3 sine 3x? This time we have an amplitude which is 3 and we have the b which is 3. So we're both changing the period and the height. Right I graphed here is y equals sine 3x. We change the b. So what's left to change? The amplitude. So what do? You just change this to 3 and change this to negative 3. This is now y equals 3 sine 3x. How about cosine? Same, same exact thing. Cosine, same thing, but obviously the graph's a bit different. Okay, instead of starting up, our cosine graph always starts instead of starting from the middle, our cosine graph always starts from the top, goes down, and oh, that's a bad drawing. Okay, it starts from the top and then comes back up. Something like this, okay, muhim. Something like this. For what's your job? Same follows the same steps. What if I wanted to do y equals 2 cosine x? Okay, what's your first step? Put in obviously 90, 4, 180, 1, 2, 3, 4, 270, and 1, 2, 3, 4, 360. Okay, your first job is to fill in the blanks, right? 2 cosine x, you know the height, we know the default one is 1, and take it down, negative 1. Is that 4 with 4? No, that's 4 with 5. Put up a bit. Negative 1 over here. Okay, the cosine graph, you have to know the points. Okay, if you don't know them, you can always just take your calculator, do cosine 90, do cosine 180, do cosine 270, and do cosine 360. You can always do this, yani, if you don't know it. Cosine 90 is 0, is 1. Or is it? No, no, sorry. Cosine, and obviously cosine 0 because we're starting at 0. It always cosine 0 is 1, 90 is 0, 180 is at negative 1, 270 is at 0, and 360 is at 1. So you graph it, you go down like this, okay, then back up like this. This is your graph of cosine x. But what do we want? 2 cosine x, and 2 is the a, it's the amplitude. So what do? Cross this out, put a 2, cross this out, put a negative 2. What if they said 2 cosine 2x? Same thing. You divide by 2, divide by 2, divide by 2, divide each coordinate by 2. Same thing. This will be 45. This will become 90. This will become 135. And this will become 180. That's it. That's how you graph. Tan. How do you graph y equals tan x? Because these all might come. Y equals tan x. This one's the most complicated one. And still, it's not that complicated. Okay? Y equals tan x. The way you graph it, always know there's an asymptote. Okay? احفظ انه الاسيمتوت اول asymptote هي at 90 degrees and the second one's at negative 90 degrees, and they repeat each other every 180 degrees. Okay, sometimes they'll give you the numbers in pi. If it wasn't in pi, the asymptotes are pi over 2 and negative pi over 2, and they repeat themselves every pi. Okay, so يعني every 180 degrees, because you know pi is 180 degrees, and 90 is pi over 2, negative 90 is negative pi over 2, and every 180 degrees and every pi. مهم, I'm gonna draw it in degrees because it's easier. The tan graph. Here, let's say I have 90, and here I have 1, 2, 3, negative 90. The graph is super simple. Okay, the height doesn't change. Okay, the height, it doesn't matter. The graph always looks like this. Oh, I fucked up. Wait, like this. It goes up in the middle and goes up. Okay, this is how you do it. Obviously, here you have an asymptote at negative 90, so it can't touch. And here at 90, you have an asymptote, so it can't touch. Again, but what happens after the asymptote? Start again from the bottom. What's the next asymptote after 90? It will be at 270. 180, 1, 2, 3, 270, which is over here. For what will happen? Start again from the bottom, goes to the middle, and then goes up to the top. If your graph looks something like this, you get correct. Let's say now I told you y equals tan 2 tan x. We're changing the a. In tan, there's no amplitude. The height is always the same. The only thing that might change is y equals tan 2x. What changes? Same thing. Divide by شو اسمه divide by 2 divide by 2 divide by 2. That's it. Okay, that's it. هيك نكون خلصنا. فرجيتكم كل الجرافs. I think I went over all the grids. Good luck tomorrow in tomorrow's exam. Inshallah everybody does good. Please make sure to bring a ruler. ويلا bye. Thank you for watching.